The nature of dark energy. Dark energy, accounting for 68% of the universe's energy density, remains a perplexing mystery in modern science, despite its true nature remaining elusive. Late 1990s observation revealed faster gravitational pull on distant galaxies, indicating the existence of dark energy, a previously unknown force. Astronomers discovered distant galaxies' redshifts in the early 20th century, leading to the development of Hubble's law, which describes the universe's expansion. Unlike gravity, which attracts matter, dark energy seems to cosmic vacuum pressure, pushing galaxies apart and causing the universe to expand at an ever-increasing rate. Albert Einstein's cosmological constant, a constant energy density in space, may explain dark energy and suggest that space itself possesses energy driving accelerated expansion. Quintessence, a hypothetical field encompassing all space, is believed to be the source of dark energy with unknown properties and potential for dynamic evolution over time. Theories suggest that dark energy effects could be explained by large-scale modifications to gravity laws, but these modifications are yet to be tested in everyday physics. Scientists are exploring dark energy through cosmic microwave background observations, large-scale galaxy surveys, and future of space missions to understand the early universe's evolution and dark energy's role. The study of dark energy's nature holds significant potential for a deeper understanding of gravity, universe evolution, and the ultimate fate of our cosmos. Remember, the field of dark energy research is constantly evolving, and new findings may change our understanding of this phenomenon at any time. Thank you for watching.